This video is about coordinate geometry. So given 4 points, determine whether the quadrilateral is a parallelogram, rectangle, rhombus, or square. So we can base this off of finding 6 slopes and comparing the slopes of the sides and the diagonals. So if the sides and the diagonals are both perpendicular, remember that these are both properties of a square. If the sides are not perpendicular but the diagonals are perpendicular, it's a rhombus. If the sides are perpendicular, which means it's forming right angles, but not the diagonals, this is a rectangle. And if neither happens, then this is a parallelogram. So in number 1, we have the quadrilateral ABCD. So we need to find the slope of the sides and then the slope of the diagonals. So the two sides that are opposite that we're going to find the slope of first are AB and CD. We need to show that at least they are parallel. So when we find the slope, remember it's x2 minus or y2 minus y1 over x2 minus x1. So in AB we have 7 minus 1 over 5 minus 1, which gets us a slope of 6 over 4, and that reduces to 3 over 2. CD has a slope of negative 3 minus 3 and 11 minus 7 minus 11. So we get negative 6 over negative 4, which also reduces to 3 over 2. So far, we know that those sides are parallel. We also need to find the slope of the other two sides. So we have the slopes AD and the slope of BC. So when we find the slope of AD, we have negative 7 minus 1, sorry, negative 3 minus 1, and 7 minus 1, so we get negative 4 over 6, which reduces to negative 2/3. For BC, we have the slope of 3 minus 7 over 11 minus 5, which gets us negative 4 over 6, which reduces to negative 3 over 2. So these slopes are the same, which means the sides are parallel. If I look at all of the slopes of the sides, so AB and AD, these are intersecting at right angles because we have perpendicular slopes because they're opposite reciprocals. So far, we know that the sides are perpendicular. Now we need to look at the diagonals. So the diagonals in this case would be AC and BD. So when I find my slope of AC, I have 3 minus 1 over 11 minus 1, which gets us 2 over 10, which reduces to 1/5. Then to find my slope of BD, I have negative 3 minus 7, and I have 7 minus 5. So that gets me negative 10 over 2, which reduces to negative 5 or negative 5 over 1. So in this case, 1/5 and negative 5 over 1 means that the diagonals are also perpendicular. So remember, if we have two sets of perpendicular sides and diagonals, that our shape is going to be a square. All right, so let's try looking at another one. Number 3. So again, we have the same shape. We have ABCD. So I need to find 6 slopes. So first I'm going to start with the side. So I have the slope of AB, and the opposite side, that's the slope of CD. So AB is y2 minus y1, so 5 minus 0, x2 minus x1, so negative 2 minus negative 4 equals 5 over 2. And then we have CD. So negative 2 minus 3 and 3 minus 5. That gets us negative 5 over negative 2, which reduces to the same thing. So we know that those sides are parallel. Then we're going to move to the next set of sides. And we're going to do the side AD and the side BC. So AD, I have negative 3 minus, or negative 2 minus 0. And I have 3 minus negative 4. So I get negative 2 over 7. When I have BC, I have 3 minus 5. And I have 5 minus negative 2, which is also negative 2 over 7. So notice that the sides are parallel, but if I look from one set of sides to the other set of sides, those are not not opposite reciprocals, so the sides are not perpendicular. So right now I know that if its sides are not perpendicular and I go back and look at my chart, I know it's either going to be a rhombus or a parallelogram, and I still need to look at the diagonals. So when I find the slope of the diagonals in this case, my diagonals are AC and BD. So when I try to find my slopes, I have 3 minus 0, and I have 5 minus -4, which gets me 3 over 9, and that reduces to 1/3. When I do BD, I have -2 minus 5, and I have 3 minus -2. Well, that gets me -7 over 5. So those slopes are not opposite reciprocals, which means that the diagonals are not perpendicular. So if both things are not perpendicular, remember then this is a parallelogram. Number 3, rectangle DELZ has the points. Verify that the diagonals are congruent. So in this case, we have a rectangle, and we know it's a rectangle. We know that D, E, L, and Z. We need to know that they're congruent. So to know that they're congruent, they have to have the same length. So we're going to use the distance formula. So we need the distance of DL, and we need the distance of EZ, and we need to make sure that they're the same. So remember that the distance formula is x2 minus x1 squared plus y2 minus y1 squared. So the first one I'm going to do for my distance formula, I have x2 minus x1 squared plus y2 minus y1 squared. So when I start to simplify, I get 10 squared plus -5 squared. So I have 100 plus 25, which is the square root of 125. So I'm just going to leave it as a square root of 125 and see if I get the same square root for EZ. So when I do EZ, I have -4 minus 7 squared plus -1 minus -3 squared. So when I start to simplify, that gets me -11 squared plus 2 squared, which gets me 121 plus 4. So they have the same square root of 125, so the diagonals would be congruent then. We can say diagonal DL is congruent to EZ because they have the same length. Number 4, rhombus MORH has the points. Verify that the diagonals are perpendicular. So remember, if we're doing diagonals are perpendicular, that's like what we did above. We just need the slope. So if our rhombus is MORH, we need the slope of MH, and we need the slope of RO. So to get my slope of MH, 6 minus -2, 9 minus -7. So we would get 8 over 16, which reduces to 1/2. To get my slope of OR, we have -4 minus 8 and 4 minus -2, which gets us -12 over 6, and that reduces to -2. So those are opposite reciprocal slopes, the 1/2 and the -2. So that means the diagonals are perpendicular. So we would say that diagonal MH is congruent to, or is perpendicular to OR, because slopes are opposite reciprocals. All right, another thing that we can do with coordinates is we can be given 3 coordinates, and we need to find the other 3 coordinates that could make it a parallelogram. So first what we're going to do is we're going to plot all three of these points in the three different coordinate planes. So we have -7, 2. We have -5, 5. And we have -3, 1. So I'm going to plot those in all of my coordinates. Now, to find the third point, we need to first find the slope between 2 points. So I'm going to pick 2 points. I'm going to pick these two. And I need to find the slope between those 2 points. So I can just count. So my slope, when I count 1, 2, 3, 1, 2, my slope is 3/2. So the first time to find the third dot is you are going to use the slope from the third point. So I'm going to go from the third point, I'm going to count up 3/2. So that point would be -1, 4. Then in the second picture, we're going to use the opposite slope. So instead of going up 3 and right 2, we're going to go down 3 and right 2. So that point would be -5, -2. And then for the last point, we need to then look at the slope between, we want to use the slope from a chosen and the non-chosen. So I'm going to look at the dot on the left. I'm going to go down 1 and over 4. So from the other circle, I'm going to go down 1 over 4. So that point. So for the third one, when I find the slope is down 1 over 4, from the other dot, I'm going to do the opposite. So I'm going to go up 1 over 4. And I get that that point is -9, 6. So now we're going to try one more example. So given the 3 points that are listed, find the 3 points that would make it a parallelogram. So we're going to do it all on one graph this time. So we're going to go to 1, 2, place a dot. We're going to go to -3, -4, place a dot. And we're going to go to -5, -2, place a dot. So I'm going to pick 2 points that are on this graph right now. And I'm going to find the slope between those. So I'm going to go down 1, 2. I'm going to go over 1, 2. So from the dot that's not circled, I'm going to do this twice. I'm going to go down 2 over 2, place a dot. Then I'm going to do the opposite slope. I'm going to go up 2 and left 2, place a dot. And I need to find my third point. So from the third point, I'm going to count from the non-circled to the circled. So when I count, I get a slope of 1, 2, 3, 4, 5, 6 right, 1, 2, 3, 4 down. So my slope would be -4, 6. Now, without reducing that slope, it would be 4, 6 from this point to this point. So now I'm going to use the opposite slope from that last point. So I'm going to go down 4 and left 6. And this would be my third point. So notice how they kind of make a triangle together. So those points then would be -1, 4, 3, 0, and -9, -8.